Okay, so we've got this problem for you where we've got a submarine and it asks what's the force on the submarine when it's 250 meters deep in the water. So let's look at this right. Oh, that's wrong. Well, I wanted to do this. So just quick pick we're going to draw here. So there it is. Here's my submarine. And we know that it's 250 meters deep. And we want to know, because of that, what is the force of this water on all of the submarine. Okay, now I have for you the length and the beam. So we're going to reduce, the length is how long the submarine is, the beam is the diameter. We're going to make things a little simpler, and we're going to reduce the submarine to just be a cylinder. So it's 560 feet long, and it's 42 feet in diameter. Okay? But what I do know for sure, regardless of how we do this, I need to convert those. So I'm going to do those first. I need those in the metric system. So I'm going to take my 560 feet, draw my line. I want it in meters, so I'll put that at the end. Make my bar, so now I have memorized, I know 1 foot. Foot's on top right here with the 560, so I know the feet needs to go on the bottom to cancel. And 1 foot, I know there are 12 inches. And then I also know that 1 inch is 2.54 centimeters. And you can see now I know the feet will cancel, the inches will cancel. I'm in centimeters. I know that there are 100 centimeters in 1 meter. That'll cancel my centimeters. That gets me to meters. So now I just run it through my calculator. So 560 times 12 times 2.54 divided by 100, that is 170.688 meters. Okay. Now I've got to convert the 42 feet. Let's see. But the only thing, everything stays the same except this number right here changes to 42 feet. I still take 42 times 12 times 2.54 divided by 100. So I can just run that back through my calculator again. Okay, so I've got that 42. So that comes out to be 12.80 meters. And I just did the same thing. Times 12 times 2.54 divided by 100. And that comes out to be 12.80. So now I know, with those two converted, that my 560 feet is 170.688 meters, and my 42 feet is 12.80 meters. So now I've got those converted. Now I just need to go on with the problem. So how are we going to solve with what we have for the force? So we want a force. Oops, let's change that. We want a force. So what formula do we have for force when we know a pressure? Well, how about force? Well, we know, let's cross that out. We know pressure equals force over area. So if I multiply both sides by the area, that will tell me that the force is the pressure times the area. So if I get the pressure and I get the area, I can get the force. So let's do the area first. Let's do the area first. So how are we going to find the area of this submarine? Remember we said it was a cylinder, right? So if I take that cylinder apart, it's made out of an end and an end. And then if I take that tube and I unroll it, it'll just be a giant square, right? So that's what we're looking for, is the area, because that force is going to be pushing all over that, or that pressure is going to be pushing all over that submarine. So the force is from the pressure all over that. So we need that whole area. So I need to find the area of a circle. And isn't the area of a circle pi r squared? But I have two of them. So that area should be 2 pi r squared, because I need to double it. Then I need the area of this tube. Well, this is just the length, isn't it? And didn't we say that length was 170.688 meters. So there's the length. Now this, doesn't it just wrap all the way around that circle? So that's the circumference, isn't it? So that's 2 pi r squared. No, sorry, getting carried away. 2 pi r. That's 2 pi r for the circumference. So all I need to do is take this side times that side to get the area of that circle. So I have two parts. I have the circles on either end for my area. So the total area of the submarine is 2 pi r squared. That's the area for the two circles, plus the square, which is just the length times the width. So that's 2 pi r times the length of the submarine. Okay? And so the length of the submarine, we know the length, we said that up above, is the 170.688 meters. Okay? That's the length. Now we need the radius, don't we? Well, we know the diameter. The diameter, remember we converted, was 12.80 meters. So all I need to do is cut it in half, right? So 12.80, divide that by 2, and that is 6.4 meters. So now I've got my radius. So now I can put all my numbers in. So the area of the submarine is 2 times pi times 6.4 meters squared. Remember, that's the area of the two end pieces, the circles, plus 2 times pi times 6.4 meters. That's one side of the square times 170.688 meters. Okay? So now, a little longer, the area. Let's see, let's multiply these out. So we have 2 times pi times 6.4 squared. So that's going to be 257.36 meters squared, plus, let's do the next one, 2 times pi times 6.4 times 170.688, and that is 6863.77 meters. And again, because of 2 meters, meters squared. So that way they'll add together. So now the area of my submarine is, we just add those two together. 257.36 plus 6,863.77. And that's going to come out to be 7121.13 meters squared. So now I've got my area. So that's the area of the submarine. So now if we go back to our formula, we've got our area, right? We just need to know the pressure. So how do we calculate the pressure? Let's go to a new page for that. How are we going to get the pressure? Well, remember, there's our picture. There's our submarine, and it's 250 meters deep. So that's what we know. So how do we find a pressure if we know a depth? Well, don't we have a formula that says pressure equals rho times G times H. H is the depth. And remember, rho is density. So if I get the density and the depth, then we've got it. And I've got the depth. The depth was 250 meters. Right? Now I just need the density. So we're in water, aren't we? So isn't that 1,000 kilograms per meter cubed? Well, be careful. How many submarines are in fresh water? That's a place we can make a mistake. We need the density of salt water. That's 1,000 40 kilograms per meter cubed. So be careful. That's a place that you can make a mistake. So now we just plug it in, don't we? Our pressure, I'm going to rewrite that formula, equals rho GH. So rho is 1,040 kilograms per meter cubed times our gravitational acceleration, 9.8 meters per second squared, times our depth, 250 meters. So that says that our pressure, we just now multiply those together, right? 1,040 times 9.8 times 250. Multiply them together. We get 254,800. What units? Well, let's look at this for a minute. Let's see here. Well, let's do this. What is a kilogram meter per second squared? Isn't that a Newton? That's a Newton. So there's a Newton. And then this meters cubed and that meters will cancel, so this becomes a meters. Whoops. Let's do that better for you. That becomes a meter squared. So this is a Newton per meter squared. And a Newton per meter squared is a Pascal, which is a measure of pressure. So that makes us feel all warm and fuzzy that the units work out. So that's 2.548 times 10 to the 6th pascals, right? Because we have 1, 2, 3, 4, 5, 6. 10 to the 6th pascals. That's our pressure. So now if we go back to our formula, check, we have our pressure. So our force is, I'm just going to rewrite that since we've got all our check marks up there. Pressure times area. So the force is our pressure, which was 2. Let's go back here, scroll down. 2.548, right? There it is right there. 2.548. 548 times 10 to the 6th pascals times our area. Here's our area. Let's go down. 7,121.13. There we go. 7,121.13 meters squared is our area. There we go. And remember that Pascal is a Newton per meter squared. So we're going to take that and multiply it by meter squared. So let's go ahead and do that. So we multiply our 2.548 times 10 to the 6th times 7,121.13. And what do we get? We get that the force is 1.8144639, writing lots of numbers we're not going to need in the end, times 10 to the 10th, what? Meter squared cancels, newtons. And newtons is a measure of force. So that makes me feel all warm and fuzzy that we got those units right. So we don't really need all those numbers. Those are not going to be. So 1.814 times 10 to the 10th newtons. Now, we have no idea what that really is. So what I'm going to do is, I'm going to divide that by 4.45 because I know something about that 4.45. So let's do that. Divide that by 4.45 and I get 4077447020. All right, 4077447020. So 1, 2, 3, 2, 3, 1, 2, 3. Okay, this 4.45 converts it into pounds. Give you a better idea. So that is, if we count that, that is 4 billion pounds. That's the force that the submarine has to withstand, that the body of the submarine, the outside, has to take.